All right, we are in our calculating digits of pi lesson. My goal today is to calculate the first 10 digits of pi. So I have my goal written down here. The little subscripts up here talk about the number of digits. I want to have this 5 calculated, and this number right here will be rounded. This entire video is based off of another YouTube channel called Math Facts, on a video that was published in 2020. I think it was published on March 17th, a bit after Pi Day. In that video, Math Facts goes all the way and rounds this number to 6. I'm pushing it one step further and making sure that this number is rounded to a 9, or at least getting a 5 in this spot. So giving some background, my goal for this is to show students how to calculate digits of pi. I'm not necessarily going to go ahead and derive where Machin's formula comes from. John Machin discovered it in 1706. Again, Math Facts does a great derivation of where this comes from. If you want to go check out his channel, I'll post a link to that down below. The general idea here is there is a formula to calculate pi, and I can say that all of this formula is roughly pi. So I can come down here and say all of this is approximating pi. And if we can find some sort of sequence to approximate arctan of 1/5 and some sequence to approximate arctan of 1/239, then we're in good shape. So luckily for us, there's these things called Taylor series, which we can expand arctan as many fractions as we would like. For this video, I'm going to go up to the x to the power 15 divided by 15 fraction, which will be used to approximate arctan of 1/5. And for my arctan of 1/239, I'm only going to go out to the third fraction. Actually, the second fraction. There's only 2 fractions of accuracy. So I write out the Machin's formula right here, and the number up here represents the term number. I've done 1, 2, 3, 4, 5, 6, 7, 8 terms of accuracy for our arctan of 1/5 approximation, and we've done 2 terms of accuracy on the arctan of 1/239. So again, this is a bit tedious to do, so I again use the same math tricks that Math Facts used, where he rewrites this out a little bit differently. So instead of doing repeated powers of 5 to the power of 9, 5 to the power of 11, I kind of just pull out 5 to the powers of 2s and repeatedly divide by 25, which is the same thing as dividing by 25 is the same thing as multiplying by 4 divided by 100, which I agree is much easier. Multiplying by 4 and then moving the decimal 2 places is much easier. So this is the formula that I'm going to be using in today's video. I'm going to be constantly referring back to this. I've also taken the liberty of figuring out how many digits of accuracy each of these fractions needs to have at each step. So for example, my very first step will be to calculate the fraction 4/15 to 3 decimals of accuracy, etc., etc. So each of these is telling me how many decimal places I need to round to. Same thing over here. I need to have 7 decimals of accuracy, 7 digits of accuracy, and then all the way eventually to 11. In theory, if I do this correctly, I should end up with these exact digits. I'm also trying to color coordinate my notes. So everything that I've done so far is in black because these are the notes that I'm doing for background. And then I'm going to be doing these moves over and over and over again. I'm going to try to color code them so you can see what I'm trying to do. And it'll hopefully be really beautiful at the end. Just as a note, I am recording this video in 2024, which is almost 4 years from when Math Facts released his video. My plan is for each successive year that I teach. So in 2025, I would like students to be able to calculate 11 digits of pi and then 12 digits of pi, and each year push a little bit further. We'll see how well that works after this video. All right, so I think if I start calculating this in Math Facts video, he did this at ×8 speed. You guys have the ×2 speed over off to this side in YouTube. You can use that function, and if you guys request, I can also just speed it up by ×8, just like he did in his video. Okay, so again, very first step, we're going to calculate 4/15. So to calculate 4/15, I'm going to go and say 15 goes into 4, and I need how many decimal places of accuracy? I need 3 decimal places of accuracy. So 4, and then 1, 2, 3 decimal places of accuracy. And I need to make sure that this looks as nice as possible. All right, so 15 does not go into 4, but it does go into 40. If I do that 2 times, it's going to be 30. Oh, I'm doing division. I need to practice my color coding. Long division, this is supposed to be in the color blue. So let me go ahead and change all of this to blue. And it's going to be 30, subtract, I get 10, bring down to 0, and 15 goes into 100. It's going to be 6 times 15. It's a triple double. That's a 90. And it's going to be 10 again. Bring down to 0, and you can see it's going to repeat that pattern. It's going to be 0.266. And decimal place goes right here. So from here, I'm going to use the right side here. Let's go ahead and arbitrarily pick a spot. We have this 0.266. And I'm now going to find 1/13. So just showing you guys what I've done so far. I've done that, and I need to do 1/13 minus this stuff. So I'm going to find 1/13. I'm going to write it here. I don't know what that is off the top of my head, so let's go ahead and find 1/13. So 13 goes into 1 times, and I don't know how many digits of accuracy did I say. This one is going to be 5 digits of accuracy. So 1, 2, 3, 4, 5. 13 doesn't go into 10. There's a 0 up there as well. 13 does go into 100 though. If I multiply by 7, that's 91. It's going to be 9, bring it down to 0. 13 times 6 is 78. Subtract. That's going to be 12, bring down to 0, 120. That's going to be 9 is 117. Subtract. That's going to be 3, bring down to 0. And 13 times 2, I guess. It's going to be 26. And we'll leave it right there. And okay, so here's where I'm going to do my decimal. So this is going to be 0.07692. This is the decimal approximation of 1/13. And I had 4 15ths right here. And I'm now going to move the decimal place because in my steps I've done 1/13. I now need to divide by 100, which is the equivalent of just moving the decimal place 2 to the left. So that's going to be color coding that red. That's going to be 0.00266. And then I'm going to, I guess I'm not going to have the 0 out front until I really need a number. Let's do the subtraction. So subtract those two. And I'm going to have to do some borrowing. You're going to turn into a 12. That means you're turning into an 8. Everything else looks good. It's going to be 6, 2, 4, 7, 0. And from here, I have now completed the following steps. I've done that step. I've done 1/13 subtracting that. The subtraction happened right there. I guess that was both. I did the subtraction and I did the long division, didn't I? Okay, so the next step is we want to multiply by 4. So multiplication is going to be dark green. So this number is going to be multiplied by 4. 6 times 4 is 24. 2 times 4 is 8, 9, 10. 4 times 4 is 16. It's going to be 17. 4 times 7 is 28, 29. And 4 times 0 is 0 plus 2. We get 0.29704. And now we've done this step. And I need to move the decimal place. Might as well do that now. Moving the decimal place. I always do in red. Yeah. So I'm going to say move the decimal place. That's going to be 0.0029704. And the number that needs to go right here is I need to do 1/11th minus this number. So 1/11th minus this number. So I'm going to say minus this number. Okay, need to figure out what 1/11 is, so let's come off to the side and figure that out. So 11 goes in how many decimal places? This is going to be 6 decimal places. So 1.1, 2, 3, 4, 5, 6. And 11 doesn't go into 10. It does go into 100 by 9 to get 99. Subtract, you get 1, bring down the 0. Still doesn't go into U. And then, hey, look, it's the same pattern, so it's going to be repeating. It's just 0.09. So I'm going to have 909. 0.090909. And it's going to be points when I subtract 704. And that's okay. So let's go ahead and do our subtraction. I'm going to round this number because I don't really need that 4. So I'm deciding, should 0 be rounded? The answer is yes. We always round here. I'm just going to say I'm going to delete U. Go to our precision eraser and erase that bar a little bit. So subtracting is 9. You're going to be 10. That means you're an 8. But we need to borrow again, so you need to be a 10, which turns into a 9, turn into an 8, and we get, oh, here we go. We have 3, we have 9, 7, 8, and 0. And just checking my notes here. Doing good so far, okay. Every time that we do this, we're always going to multiply by 4. So we just did the subtraction problem here. We found 1/11 here. Now I'm going to be multiplying by 4. So I'm multiplying by 4. Four times 9 is 36. 4 times 3 is 12. 13, 14, 15. 15. 4 times 9 is 36. 37. 4 times 7, 28, 29, 30, 31, 31. 4 times 8 is 32, 33, 34, 35, 35. And 4 times 0 is 0 plus a 3. So you get 0.351756. Looking good so far. Okay, so we just did the multiplication of 4. Now we're going to move the decimal place. Moving the decimal place is going to make this 0.003517556. And again, this is probably where I'm going to decide what sort of rounding I want. So I'm going to round this one to say this is really 0.6 here. So, oops, I'm going to change this to my stroke eraser. 0.6. And then I need to figure out what 1/9 is. I happen to know this off the top of my head. It's 0.1 repeating, but in case you want to, see that, if I have 9 going into 1, how many decimals? Precision do we need? 7. So 7 zeros. 1, 2, 3, 4, 5, 6, 7. 9 does not go into 1, but it does go into 10 by 1. And I'm going to subtract here, and I get 1, and I bring down, oh, it's another 10. 10 and 10 copied, so it's going to be 0.1 repeating, which is just 0.1111, all of these ones. So because I'm doing this to 7 digits of accuracy, I'm going to have 7 of these ones. 1, 2, 3, 4, 5, 6, 7. And I already rounded the red, which means I need to do the subtraction. So I'm going to do my subtraction. What is that here? I need to borrow. It's going to turn into 11. That means you're a 10. You are going to be 10, 10, 10, and you're 0. Okay. So subtracting straight through, this is going to be 5, 3, 9, 5, 7, 0, 1. Excellent. Just checking off on our list what we're supposed to do here. So we did the subtraction problem just right now. We found 1/9 using long division, and now the next step is to multiply by 4. So multiply by 4. What do we have? 4 times 5 is 20. 4 times 3 is 12, 13, 14, 14. 4 times 9 is 36, 37. 4 times 5 is 20, 23. 4 times 7 is 28, 20, 30. 4 times 0 is 0, plus the 3. 4 times 1 is the 4. I get that 0.43033740. Okay, nice. So check that off. We multiply by 4, and then I'm going to move the decimal place. So moving the decimal place is going to make this 0.00430374, and I guess rounding these two decimal places means I have a 4 here. And then from here, I'm going to figure out what the fraction 1/7 is to do my subtraction problem. I think I have it memorized. I think it's like 0.1428. I want to guess. Can I guess here? 0.14285. What number have I not used? 7, I guess. And then it repeats again, 1, 4. I think that's what it is. Let's go ahead and double check though. Just trying to show off my memorization here. If I have 7 goes into 1. Okay, how many decimal places? 1 more, right? So it's 1, 2, 3, 4, 5, 6, 7, 8 now. Here's our division problem. So 7 does not go into 1. It does go into 10. If I do a 1 here, subtract the 7, it's going to be a 3. Bring down the 0. 7 times 4 is 28. That's going to be a 2. Bring down the 0. 3 is too much. 2 is good enough. 2 for 14. Subtract, that's going to be 6. Bring down the 0. 8 is 56. Subtract 4. Bring down the 0. 7 times 5 is 35. Again, we're going to subtract. That's going to be 5. Bring down the 0. And times 7 is going to be 49. Subtract, bring down the 1, and it starts again. So we started with a 1, 0, we're ending with a 1, 0, which means this is going to repeat right here. Oops, it's a bad line. This is going to repeat, which means I have another 1, 4, and I think that's exactly what I put over here. Nice, I got it correct. So from here, we're going to do our subtraction. So subtract all of this. And don't need to borrow. I'll need to borrow. Make you 11. That turns you into a 6. Any more borrowing, you need to be a 12, which turns you into a 3. All right, let's subtract. This is going to be 4, 3, 5, 5, 8, 3, 1. Let's see, 1, 3, 8, 5, 5, 3, 4, 0. Nice. All right, so let's check off our list of what we've done so far. We moved the decimal place. We found 1/7, and we just did the subtraction. Next step, again, multiply by 4. Feels repetitive, but we got this. If we multiply this by 4, what is this going to be? It's going to be 0, 16, 12, 13, 4 times 5 is 21, 4 times 5 is 22, 4 times 8 is 32, 3, 3, 4, 4 times 3 is 12, 3 more 15, and 4 times 1 is 4, plus the 1 is 5. So 0.55421, 360. Nice. And then let's move the decimal places right now. This is going to be 0.0055421, okay, and then I'm going to round this number. 6 and 0 rounds to just a 6. Then I need to find the decimal approximation of 1/5. 1/5, as a reminder, is the same thing here as 2, or it's not approximately equal to, it is exactly equal to 2/10, which is just 0.2. So this is 0.2 with as many zeros as we care to have. And then I'm going to do my subtraction problem in green, lime green. Yes. All right, we need to do some borrowing, turn into a 10. Wow, everything else turns into a 9, doesn't it? 9, 9, 9, 9, 1. Okay, so we have 4, 6, 8, 7, 5, 4, 4, 9, 1. Okay, so what have we done so far? Just logging. We multiplied by the 4 a while ago. We moved the decimal place. We did the subtraction problem after finding 1/5. And after doing the subtraction problem, which we just did, our next step, you guessed it, multiply by 4. Let's find this. So multiply by 4. Four times 4 is 16. 6 times 4 is 24, 25. 4 times 8 is 32, 33, 34. 4 times 7 is 28, 29, 30, 31. 1. 4 times 5 is 20, so it's going to be 23. 4 times 4 is 16, 17, 18. 4 times 4 is 16, that's 17. 4 times 9 is 36, 37. 4 turns into a 7, and I get 0.777831456. Okay. And next thing, we move the decimal place. So this is going to be 0.007778314. Okay, now I'm going to round. This should round up to a 6 now. So rounding to a 6, and the next fraction that I need is 1/3. Most students know what 1/3 is, but if it helps you, it's the same thing as 3/9. Anytime that you divide by 9, you just repeat that number over and over. This is going to be 0.3 a bunch of times. All right, and then we do a subtraction problem. All right, things are going to need to be borrowed, so it's going to turn into a 13, turn into a 12, turn into a 2. Everything else looks good. That needs to be a 13, which means you are 2, actually 12, you are 2, 12, you are 12, and you are 2. All right, so it's going to be 7, 8, 1, 0, 5, 5, 5, 5, 2, 3. Excellent. Just checking off what we've done so far. I'm guessing the next thing we're going to do is multiply by 4. But we multiplied by 4, we divided by 100. We did the subtraction problem after finding 1/3. Again, the next thing that we need to do now is to multiply by 4. So here we go. I'm going to say multiply by 4. 4 times 7 is 28. 8 times 4 is 32, 33, 34. 4 times 1 is 4, plus a 3 is 7. That's going to be a 0. That's going to be 20. It's going to be 22. It's going to be 22 again. It's going to be 22 again. It's going to be 8, 9, 10. 10. 4 times 3 is 12, which is actually 13. And we actually have our first number that's over 1 now. So 13022200748. Nice. So we multiplied by 4. I think the next fraction that we need is just 1, which is kind of nice. So this is just going to be 1 right here. Let's move. I think we still need to move decimal. Let me check my roadmap. So we are going to, we just multiplied by 4, right? We're going to move the decimal and then do 1 minus the move the decimal. So this is going to be 1. This is going to be 1.1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I think we want 11 digits of accuracy. Yeah, indeed, we want 11 digits of accuracy when we do that subtraction problem. And this number over here is going to be 0.01302220007. Okay, and then this number here is going to get rounded to a 5. And we're going to do a subtraction problem now. All right, everything needs to be carried here. So this is going to be a 10, and then everything else is going to be a 9. subtracting 5, 2, 9, 9, 7, 7, 7, 9, 6, 8, 9, and nothing up front. 9, 8, 6, 9, a bunch of 7s, 9, 2, 5. There we go. All right, so the last little step for that first piece is we just did the subtraction problem. We found the 1 that's just 1. That's nice and easy. We now need to multiply by 4/5, which is the same thing as 8/10, and 8/10 is just 0.8. So if I just multiply by 0.8 here, I'm good to go. And that's going to be a multiplication problem, which is going to be in dark green. So multiply by 0.8 is what I'm asking for. I'm doing that to 12 decimal places. Multiply by 0.8. So we're going to multiply this by 0.8 and multiply. All right, here we go. 8 times 5 is 40. 8 times 2 is 16, which goes up to 20. 8 times 9 is 72, 73, 74. 8 times 9 is 72, which goes up to 79. 8 times 7 is 56, which is going to turn into 63. Did I do that right? Hold on. 8 times 7, 56. Yeah, so that's 63, good. 63, and 8 times 7 is 56, which is going to go to 62. 8 times 7 is 56, which again is going to go to 62. 8 times 9 is 72, which goes up to 78. 8 times 6 is 48, which goes to 55. 8 times 8 is 64, which goes to 69. And 8 times 9 is 72, which goes to 78. And normally, the decimal place would go right down here, but you are also multiplying by a decimal here, which means the decimal is actually going to be right here. So it should be 0.789582239 with double zeros. Okay, so what is this first half? We're done with the first half, by the way. This is an approximation of arctan. I'll write this over here as a note. This is approximately equal to arctan of 1/5. I guess it's 4 arctan of 1/5. So the next thing that we need to do is we need to find this next piece. If I could just find this, then I can subtract the 2 and then multiply by 4 for my final step. So do I have enough room to do this all? I think I'm going to use the back side of the paper. So I need to find, I'm going to start with a third now on the back side, and then I'm going to divide that by 239, divide it by 239, do 1 minus that number, and then divide by 239 again. So there's lots of division by 239. So let's start with 1/3 to 7 decimal places. So if I have 1/3, that's going to be 0.3 to how many decimal places again? I already forgot. 7. 1, 2, 3, 4, 5, 6, 7. That's 1/3 here. And I need to do that number divided by 239. Whew, okay, so really what I'm doing here is I'm saying this number goes into 239. I think that's a good spot for it. So 239 goes into that with long division. Okay, I don't know my times tables for 239 very well, so I need to multiply 239 and figure out what those time tables are. Let's say if I multiply by 1, that's obviously 239. If I multiply by 2, I'm going to need some more room here, aren't I? I'm going to move you over here. Hopefully that's enough room. If I multiply that by 2, what is that going to be? That's 478. If I multiply by 3, if I just add another 239 to that, that's going to be 717. Okay, if I multiply by 4, I add another 239 to that. If I add another 239 to that, that's going to be 659. Okay. I'm just going to keep adding 239 to make my new times table here. So this is going to be 1,000. I can't do that fast. Okay, it's going to be 5, 9, 1. Yeah, 1. Okay, good. Let's add on another copy. and we get 4, 3, 4, 1. Adding on another copy is going to give us 3, 7, 6, 1. Adding on another copy gives us 8, which is 2, 1, 9, 1. And finally, 9 should be 1, 5, 1, 2. I'm worried that I made a mistake, so let's go ahead and add on another copy of 239. And that's going to be 0, 9, 3, 2. Okay, yeah, check it out. This number and this number are the same. This was a 10, so I'm just checking my work. That worked. Okay. So there's my times table. This will come in handy multiple times, I think 3 different times. So here we go. What is 0.3 repeating divided by 239? Well, 239, I'm going to move the decimal place right above here and say it does not go into 3, it does not go into 33, it does go into 333, and let's maybe, I'm going to move you around, but for now, you're going to go right there. There's one copy of it, and that's 239, and if I subtract, that's going to be, what is that going to be, 494. So if I bring down a 3, 943, 4 is really close, but it's unfortunately a 3. And then 3 is going to be 717. So what is that going to be? It's going to be 6 carry, so 226. And then I'm going to bring down 3. So that's going to be 5 here, and that's 1,195, 1195. That subtraction problem. I'm not sure how to work very well in my subtraction problem. And what is that going to be? It's going to be 8, and I have to borrow, so let's turn it into a 5, so that's a 6. Did I do that right? 5. I'm going to do some notes here. So this is going to be 13. It's going to be into 5. So it has to go up 6. Yeah, that's right. So just 68. Get rid of that. And then bring down another 3. 683. That is going to be a 2. Something has happened that is not correct. I'm trying to check my work. My answer key is telling me that that number is wrong. Where did I make a mistake? Oh, silly. This number needs to be a 2. Okay. The number needs to be a 2, which means it's actually, oh my goodness, a much bigger number. It's going to be, okay, so this is wrong. This is going to be 2,263. That has to be a 9. Okay, that's my mistake. That's a 9, which is going to be 2,151. Subtract. And what are we going to get here? This is going to be 2,110. Bring down 3. 1,123. Could have used a 5, but it's so close. It's going to be a 4. So 4 is going to be 956. And my subtraction problem again. So it's going to be 7, 6, 1, and then bring down another 3. 1673. Oh my God. No way. Did that really work out? It was exactly 7. Okay, I didn't mean for that to work out, but that's awesome. Might as well go on to another decimal place since I have an easy one. It's 1673. If I subtract that, it's going to be 0, and that means it doesn't go into it any times. Cool. How many digits do I have here? 1, 2, 3, 4, 5, 6, 7, 8. How many did I need? I needed, I guess I only needed, oh yeah, I actually did need 8. when you do that step. Okay, and then I have my number, and I'm going to do what to it? I have done my long division of here and here, and I need to divide it yet again by 239. So take my answer, divide it by 239. So my answer was this 0.0139470, and I divide that yet again by 239. Move this over to right there, and we're going to say 239 goes into that. 239 goes into that. All right, well, luckily there's a bunch of zeros at the very beginning. No, still can't go into 139. It can go into 1,594. I'm going to go ahead and move this table down so I can see a little bit better. 1,394 would be a 5 there. So let's say 5. And if I do a 5, that's going to be 1195, 1195. Subtraction, that's going to be 199, and then bring down a 7, 1997. Okay, that's going to be an 8. And 8 will be 1912, 1912. Do our subtraction problem. It's going to be 5, 8. That's it. And then bring down a 0. 850 is basically a 3. Excellent. To have 8 decimals of accuracy, 1, 2, 3, 4, 5, 6, 7, 8. I have 8 decimal places of accuracy, and we have just done this step right here. And now what I need to do is I need to do 1 minus my answer. So here comes my subtraction, right? So I'm going to have 1 point, I need 8 decimal places. 1, 2, 3, 4, 5, 6, 7, 8. And I'm going to be subtracting the number that I just found, which is there's 5 zeros. 1, 2, 3, 4, 5, and then 5, 8, 3. Okay. Lots of borrowing here. It's going to turn into a 10, 9, 9, 9, 9, 9, 0. What do we have here? It's going to be 7, 1, 4, and the rest are 9s. Okay, so we just did this step right there. And then our final step for this second half of the problem is divide by 239 again. So let's go ahead and rewrite this number. There are 5 9s and 4 and 7. 5 9s and 4 and 7. I'll do it right here. 1, 2, 3, 4, 5, and then 4, 1, 7, and divide it by 239 again. All right, so I'm going to slide down our multiplication table. Right there. Nice. All right, so it does go into 999 because I can go into it 4 times. 4 times would be 956. So there's a decimal place. There's 2 zeros there. I'll do a subtraction problem. Luckily, these are kind of easy. This could be 3, 4, bring down 9. So 439, it has to be a 1. So it's going to be 239. And if I subtract those, it's going to be just 200. Then bring down a 9. That's going to be 2009. That's going to be an 8, and 8 times 239 is going to be that 1912. Subtraction problem again. It's going to be 7. It's going to turn into a 9. It's going to be a 0. So just 97. Bring down the 4. 947. Dang, it's close to 4, but you unfortunately have to do a 3. Wait a sec. Do you have to do a 3? 974. Wait a sec. No, you have to do a 4. Silly. Mr. Stell. This is going to be a 4 because a 4 gets to 956. 956. Subtraction. And it's going to be an 8, an 18, bring down 1, 181. Oh, you can't do that, so 0 here. And I'm realizing, how many decimal places of accuracy do we need on this final one? We need 11 decimal places of accuracy, which means I'm just going to have some zeros in here, I guess. It feels a little bit like cheating here. I know I have a 0 there, so I can come down here. Do we have 8, 3? I'm just going to go ahead and move this over here, give myself some room. We need 11, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Let's see what happens over here. I'm just going to go like that. Bring down the 7, 1817. That's going to be a 7. And when I do a 7, it's going to be 1, 6, 7, 3. Subtracting to 4, 7 goes to a 4, goes to a 1. Bring down, we don't know, so I'm just going to say 0 for now. 1440 is a 6. And 6 is going to be 1434 and 434, which is really close. It's only 6 away. Bring down a 0. It doesn't work, so we're going to say a 0. And if I bring a 0 in here, to get close to 600, I would put a 2 here. How many decimal places? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So I have 11 decimal places. All right, so this is an important number. What we have here, I'll put a note here. This is about arctan of 1 over 239, I hope. We'll see. So back to our roadmap. We did do long division for that one. Next, we need to say this entire first half right here, we're going to subtract the second half that we have over here. So I think I have enough room on the front side to do this. So the first number I have is 0.78. Let me just copy paste here. This decimal place right here, we're going to copy and we're going to paste. So this number, let's move it right there. Here we go. I'm going to be doing a subtraction problem, and I need to take this number right here. I don't know if I have enough room to do this. Let's see. I'll grab all of the stuff. Copy. That's our other arctan approximation. Paste. And subtract the 2. Okay, so I can do that. I have enough room here. If I subtract the 2, I get, there's nothing there, so I'm just going to ignore that. And 0 minus 2, can't do that, so it's going to turn into a 10. Borrow, anything else that needs some help? That needs some help. Here we're going to turn it to a 12, 17, and a 4. Everything else should be good. So this is going to be 8, 3, 3, 6, 1, 8, 9, 3, 5, 8, 7. So 7, 8, 5, 3, 9, 8, 1, 6, 3, 3, 8. Excellent. And here is the moment of truth. So what we just did is we just did the subtraction problem. We've done literally everything in here with the exception of 4 needs to be multiplied into this entire thing. So this is, in theory, we're going to get pi here. Let's see. Times 4. Do we get pi? I'm really praying that we do, because this was a bit of work to set up. So here we go. 4 times 8. 32. 32. 4 times 3 is 12, 13, 14, 15, 15, 12, turns into 13, 13, 6 and 4 is 24, which is 25, 25, 4 times 1 is 4, 5, 6, 4 times 8 is 32, 32, 32. 4 times 9 is 36, 37, 38, 39, so 39. 4 times 3 is 12, 34, 15, 15. 4 times 5 is 20, 21, so 21. 4 times 8 is 32, 33, 34, 34. 4 times 7 is 28, 29, 30, 31. So it's 31. And I have made a very silly mistake that I think I can catch. I said that 4 times 8 is 32, 33, 34, and I wrote 33. This should be a 34, so my bad. 34. Well, decimal place goes right there. How close were we? So I'm going to kind of zoom out here, compare. I should have 141. Ooh, I'll put this in the highlighter though. 141, 141, 592, 592, 6535, 6535. Oh my God, finally got it. So this is an improvement on last year's class where we all got a 6 here. We now got a 5 here. We took it one step further. We went all the way to 15 instead of 13. Wow, we did it, guys. Let's go ahead and make things look a little bit neater here. We can have some room. Put this right there. Wow, that was accurate. So that's the 10th digit right here. This is the 10th digit. That is excellent. Wow. All right, so thank you guys for watching. There is, again, the zoomed out picture of the front half, and there is all the back half. Thanks for watching, guys.